Before we jump into applications, we need to learn about two important devices that are available for use in TinkerCAD. The first one is a power supply and the second one is a function generator. So in the previous video we did design a circuit. The circuit was powered by a battery, so that seems to be sufficient, but in applications we have different circuits which would need voltages about 9 volts. We do have a 9-volt battery here. Maybe you can connect a couple of batteries in series to get, like, say, different voltages, and like say you can also add coin cell batteries, or like say 1.5 volt regular alkaline batteries to get the source you need. But there is a device called Powersupply that you can adjust the dials and then get the required power supply. So let's start with that. So a power supply, to get that in, just like type in power supply and then you have that, just click and drag. So here's our power supply. So if you see the dials, you can get anywhere between 0 to 30 volts here, and then amperes, you can't draw more than 5 amperes here. So that is the specification of this. So let's get rid of that, and we'll try and build a simple circuit. Maybe I'm gonna bring in 3 resistors, like that should be sufficient. Maybe I will change the resistance of a couple of resistors, and I'm gonna probably do a circuit like this. So we call this a Y network. So maybe I'm going to so this is my circuit right now, so I think I'm completely happy with it, but like this should be okay. So now let me start the simulation and see what happens here. So there is 846 microamperes current flowing to this. So maybe let me increase that to 20 volts, or you can just like type it in here, or maybe let me stop the simulation and start simulation. 20 volts. Okay, so if I wanted to find the current flowing through resistor, like through this resistor to the other one, so I can add a multimeter. Add multimeter here. So I want to find the current flowing through this, so I will change it to amperes. Positive, I'm going to connect to that, and then the negative is going to be connected to this resistor. So I'm just trying to find the current that is flowing through this path. So let me turn it on. So the current flowing through this path is 308 microamperes, and let's do another thing. Okay, if I wanted to find the voltage across these, so this is in voltage mode already, so let me connect the positive here, negative here. So this is going to let me know the power the voltage that is dropped across this resistor. So let me turn it on. So 16.9 volts is being dropped in this circuit. So if this is the case, what would be the voltage that is dropped across this parallel resistors, this set of resistors? So the reminder, so 20 volts, so you have 3.1 volt, say 3.1 volt will be the power that is dropped across these two resistors. So maybe why don't we just check that by bringing in another multimeter, and then I will connect it to this junction and this junction. So I'm trying to find the power or like see the voltage for For some reason I'm saying power all the time. To find the voltage that is dropped across these two resistors together. So we know that like this was 16.9, so that was the voltage that was dropped across these, and the entire voltage, or like the voltage supplied to this system, is 20 volts. So the remainder have to be dropped right here. So 3.1 was our guess. Let's see whether we have guessed it right. So it's pretty close. So this is again like the resolution of this. This might have been 16.92. So here we have 3.08, close to 3.1. So this is good, and here we confirm our voltage rule that we saw in the first subsection of this module. And that is how we, maybe one more thing we will do. Why don't we find the equivalent resistance of this circuit? So I'm going to connect the positive right here and the negative right here. Start simulation. So it's altogether 5.91 kilo ohm. So that is the equivalent resistance of this circuit. So this is good, and now let's try to do another circuit. Maybe now, instead of using a resistor, let me bring in a diode. Instead of, this is the standard diode, like where we said that like when you apply a voltage across these, when the current flows through these diodes, the energy, or like the power that is dissipated by these diodes, are converted into heat. In light emitting diode, is converted into light. So instead of using the regular diode, like let me bring in the same LED, light emitting diode. I'm gonna just flip it around, and you can have the current limiting resistor before or after, doesn't matter. But now, instead of using a DC source, I'm going to use an alternating current source. So that is the function generator. So this will generate signals anywhere from 1 Hertz to 1 megahertz. 1 megahertz is like 10 power 6 cycles per second. That's close to 1 million cycles per second. That's 1 megahertz, and a voltage somewhere between 0 to 10. And you also have an offset. So usually we don't have to use this offset. I'm gonna change that to 0. And one more thing is, I always wanted to use sine wave because that is what we will be receiving in the mains. And now I am going to wire the circuit. So cathode goes to the negative. So you can place the current limiting resistor in the front of a diode or after the diode, so that doesn't matter because it is going to be connected in series anyways. In series you sum up the resistance, so it doesn't matter where you put it. In series it's going to limit the current anyways. It doesn't have to be it doesn't matter like whether it is up front or like in the end. So now I have completed the circuit. Okay. Now this is done, and I'm just going to change the frequency to 1 Hertz, which means 1 cycle per second. 0.5 second will be the duration of the positive half cycle, and 0.5 seconds will be the duration in the negative half cycle. Okay, so that is done. Now I'm going to use another device called a scope, or sometimes it's called a oscilloscope. So this will let you see the waves actually. So let me do that as well. So I'm going to connect this positive to this battery and or sorry, to this terminal, and negative I'm just going to ground them. Okay, so let me run this. Before that, like 1K is reasonable, not too bad. Okay, let me run it this way. Okay, so this is what I wanted to show you. Maybe instead of 10, 5 volts, I'll do 10 volts. So you have a positive and negative half cycle. So this is a sinusoidal wave. So what happens is, as soon as the voltage across the anode and the cathode increase, or like say the anode and the cathode goes above 0.7 volts, so it turns on. So that is when it turns on. During the negative half cycle, it is turned off. So to check that, we will use another scope. Maybe I will just place it there. And now I'm just going to connect. Wait, this might be better. Don't want that anymore. So I will connect the anode and the negative terminal to the ground again. So let's run the simulation. So this is a sine wave. If you see, only the positive half cycle appears here. The negative half cycle doesn't. So that is a oscilloscope. Like, you can use this for testing your circuit. But again, like you might do another test to verify this actually. So instead of having this just one diode, like, why don't we use another diode, another light emitting diode, and we'll bring that in. And here I am going to reverse bias. So what I'm going to do is maybe I will just run this circuit like that. So here I'm doing exactly the opposite. So here I have connected anode to the positive, but here I'm connecting cathode to the positive. Likewise, I am also going to connect the negative to the positive. So what happens is, during the positive half cycle, this is going to be turned on, and during the negative half cycle, this will be turned on. So let me turn on the simulation. So if you see, it kind of alternates. So that's what happens. And again, if you see, the change is not instantaneous. It is like kind of slowly increasing, going to the maximum, and slowly decreasing. That is the sine wave. But let's say if we have a square wave, what will happen is just like it will just switch back and forth. This will be more of an instantaneous. So you don't see that gradual increase and gradual decrease. So this is how you use a function generator to test your circuit. Yes, now you know how to use a power supply, how to use a function generator, and how to use oscilloscope. And this should be sufficient for you to handle the questions in the applications. Maybe one more thing I would like to let you know here is, maybe I thought like I would do another problem there, but like maybe now we'll do that. So why don't I create the same circuit with a breadboard? So there are like 3 different kinds of breadboards here. This is the standard breadboard. There is a small breadboard, and there's also a mini breadboard. Doesn't matter what you use. So you just like bring one of those in, and if you see, as soon as you click, so the highlighted ones, like everything that is green is all connected. So those are the power rails, and here these are the these are the holes that are used for components actually. So as a good practice, always what you do is, like, as soon as you have a power supply, instead of this, maybe I'm gonna use a DC power supply. So I'm going to use that, and I will always wire these first, and then you can also wire these ones. So negative to negative, and positive to positive. So now all my power rails are having the supply. So once I have the components in here, then I could do what to say. I can kind of take or draw power from these power rails, so that should be no problem. Let's do a small circuit. Before I do it on the breadboard, like, I will do it the usual way, so that is going to be pretty easy. So let's say I will bring in this resistor. Okay, how do I connect this? Maybe, like, let's do this. So this is my circuit. 1, 2, 3. Maybe I'll rotate this. Okay, so let's say this is my circuit, and probably I will use another power supply, and I'm going to and this is going to be a resistor that is going to be in between those. Oh yeah, and if you accidentally press something wrong, or like say if you wired it weird, you can press the escape key always to get rid of it. Click drag, that is what I'm doing. So this is the circuit. Okay, so now let's say I wanted to find the current that is flowing through this resistor. I'm going to use a meter, and I want to find the current. So I'm going to use this is my circuit. So I have this. If I run this circuit, then I will know maybe the current is too small. I'm going to increase the voltage. Since I'm doing this really random, still it's not much. Maybe I should reduce the current, like overall current is like less, so this is going to be really less. So any current less than, like, say 10 microamperes will not show up. So the circuits should be designed accordingly. No, even with that, like, that doesn't work. So these are all 1 kilo ohm resistors. So let me do 500. There's 500 ohms, and maybe here I'll do 250 ohms. Okay, so now it's reasonable. So it's 7.04 is the current that is flowing through this resistor. So now I am going to start simulation, and I'm going to do the exact circuit here in a breadboard. So here, like, it is easier to do something like this, a circuit like this, and say run it and find out the current. Like, it's much easier. But if you're doing it in like, what I say, on a breadboard for real, then breadboard is easier than doing something like this. Actually, breadboard is the way to go. So let's do this. So I need 5 resistors, so I'm going to probably bring in the same. So I'm going to click on that, and I'm going to just copy paste. So Control C, Control V, and then let me do it like that. Let's see, I think that should be okay. Control C, Control V. For now, I'm just like bringing all those in. Control C, Control V. Maybe I can just move that here. And I had to do, maybe instead of that, I will just like, why don't I just like put it in there and put that here. So that is taken care of. So the power supply, I'm directly drawing the power. So yes, this is positive. From positive, I'm drawing the power, and then I will use this to connect those. So it is exactly in the same fashion, and I will copy that and paste and bring it down here. Copy, paste, and there's another one. So this one I can't. Can I? Yeah, why not? Like, I can go down here and connect it to negative. Maybe we'll do that. No, I think I have to pull it up there. And one more thing you will have to do is, again, I have done this connection. Oh, yeah, since I've connected here, these two resistors are connected, but I need a wire to connect this and this actually. So I'm going to run a wire from here to here. So now this is connected. So all these three, so just let's go node by node. So this node, that is this node actually. So here you have the power connected, the positive is connected, and then like you have these two resistors connected to the same node. So you have 3, 1, 1, 2, and 3. So that's done. And then here again, like you have 3. So you have 1, 2, and 3. So that's that. And you have this one. You have 1, 2, and 3. 1, 2, and 3. And likewise, we already confirmed this one. And you have a wire running from here to this junction. Yes, we did that. And that goes to the negative. And the negative is wired back through that, and through that. So that is our circuit. It's exactly the same thing. Like, the only thing that is missing is a meter. I'm going to bring in the meter. And okay, I need to find the current like that is flowing through this one. So instead of doing that, I'm going to do another thing. Actually, I'm going to drag it right here, and from here I'm going to connect it to the positive of the meter, and then the negative actually goes into that. Okay, so if I have done the circuit properly, the current that is displayed in this, oh, this is not current, this is voltage, this is okay. And let me make sure how much voltage is. That is 30 volts. So let us make this 30 volts as well. So if I had done a good job, so the current reading in these 2 meters should be the same. So let me start simulation. Yes, 7.04. So I've done a good job. And let's say if you wanted to take a screenshot of this, I'm going to start simulation. I just wanted to move that here. And if I wanted to take a screenshot of my circuit, I will just click get rid of these. And now, so I will kind of zoom in, and you can use SN, the snipping tool, to create a screenshot. So that should be sufficient for the assignment. Oh, and one more thing is, like, make sure you run it like when you take a screenshot. So, and again, like sometimes, say if you're doing like a rectifier or something, you want the light bulbs to be glowing, so make sure you snap it at the right time. So that is the most important thing. So that is a screenshot, what I would expect from you in the assignment. And what else shall we do? And that is good. We have that. Yes. Okay. So this should be, I guess, a good introduction for TinkerCAD. You can practice the same in your TinkerCAD, in your machine, and following that, you can start solving the application problems. So this should be useful for that. And in the next video, we will go over the problems, assignment problems in the applications.